Okay, time to look at a new kind of notation, interval notation. See, we're accustomed to this notation right here where we say, okay, x is greater than or equal to a and less than or equal to b. Well, here's the thing. This can be kind of bulky. And sometimes what we want to do is just talk about, we want to real quickly describe an interval. And we don't want to have to write this out. We'd like something a little bit more streamlined. So what we'll do oftentimes is we'll write this. Instead of this, we write this. And see, we don't have to worry about x less than or equal to, greater than, or anything like that. We just write it as a little bracket here. Now notice it's got a little square top, square bottom. A, that means A can be included. So x is greater than or equal to A, the number on the left, less than or equal to the number on the right. This is interval notation. Now, we don't have to have the equality included. In other words, you might say, well, what about a situation like this? X is greater than A, less than B, but not inclusive. So we don't have, X can't be A and it can't be B. Well, we would represent that this way, a little curvy instead of a little square bracket. So we say this right here is an open interval, this right here is a closed interval. Now, we don't have to have altogether closed or altogether open. We could have a half. So look at this one. X is not going to equal to A. It's strictly greater than A, but less than or equal to B here. So that's a half open, half closed, and we could write that this way. Notice A, it's got little parentheses here, and notice A is not included. B, however, has the little closed bracket there. And it is included. So that's half open, half closed. We could talk about A being strictly greater than A, where we don't have an A and B here. We just have X is bigger than A. Well, what we would usually do with that is write it this way. Notice X is not equal to A. It's strictly greater than A. So it starts at A, but not including, and goes to infinity. Now, we never, ever put a closed bracket by infinity, because x is not going to obviously it's not going to equal infinity. We're talking about direction here. We're saying it starts at A, but doesn't include it and goes forever to the right. Now let's look at this one. X less than or equal to A. Well, it comes from negative infinity to A, and it can include A. So we've got this. Now we could also have situations like this where x is less than or equal to A, or x is greater than B. And we want a way to say, okay, it could be this or that. And this is what we do. We say it's x can be in this interval, negative infinity to A, including A, or x could be in this interval between B and infinity. Okay? So this is the way we represent a union. It's the union of these two. So x could be in either one of these. Okay, we could have something like this. X is greater than or equal to A, and x cannot be B. Remember, B is bigger than A, so we're thinking we're starting at A, we're going to infinity. However, we can't let x be B, so we've got to just step over B. So here's what we have. We have the interval from A to B, little parentheses here, and then I'm going to step over B and pick up on the other side and go to infinity. So x goes from A to B and then picks up on the other side of B. And it doesn't include B, right? Stops just short, picks up on the other side, and then continues its journey to infinity. But this is interval notation.